Hi, this is Nat, and this is your video lesson on making and reading stem and leaf plots. We'll talk in a couple minutes about what a stem and leaf plot is used for in terms of what types of data it's good for and that sort of thing, but it'll help to actually understand what it looks like before we do that, so let's start there. Like any graph, a stem and leaf plot is used to display a set of data. So here's a list of data right now. If I want to put that into a stem and leaf plot, I'm going to start by drawing this standard T shape. And just like any graph, I'm going to be trying to do it neatly, so you're going to notice that I'm putting my lines on the lines, and the left side is always the stem, and the right side is the leaf. That's where the name stem and leaf comes from. When we put data into the stem and leaf, we divide every single number that we have in our data set up into two pieces, the ones place and then anything that comes after that. Let's take a look at this 18 up here. That's the lowest number in the data set, so that's the one I'll start with. I'm going to break it into two pieces. The ones place is an 8, and it has a tens place in this case, which is a 1. I'll write the ones place in the leaf, and I'll write anything else in the stem. So for 18, I'm going to write 1 in the stem for the tens place, and I'll write 8 in the leaf for the ones place. The next number in our list here, numerically least to greatest, is this 19. I'm going to do the same thing. I'm going to split that into two pieces, a 1 and a 9. You're going to notice I already have a 1 down here in the stem, so I actually don't have to repeat that 1 again. That's one of the things that makes a stem and leaf plot a stem and leaf plot. We don't repeat tens values in the stem. We just use the same ones over and over again. So the 1 is already there, but I'll go ahead and put the 9 in next to the 8. My next highest number, or lowest number, is going to be this 24. Same deal, I'm going to break it into two pieces. I see a 2 in the tens, and I don't have a 2, so I'll go ahead and write a 2 in. And I have a 4 in the ones. So I'll write a 4 in the ones place, or in the leaf. Here's another 24. I already have a 24, but I can't just ignore it. The 2 is already there for us, so I'm not going to repeat anything in the stem ever, but the ones place can repeat. So I had 24 before, now I've got 24 again. Then I go to 25, which I'll write by adding a 5 to the leaf. Here's another 25, so I'll put another 5 in the leaf. Here's a 28, so I'll put an 8 in the leaf. I get to my 36 over here, and I'm going to put a 3 in the stem, and I'll put a 6 in the leaf. And then finally I've got this 41. I'll put a 4 in the stem, and I'll put a 1 in the leaf to be 41. This didn't come up in our original data, but one of the things that messes students up all the time is what do you do with data that only has ones values? So for example, the numbers 7, 8. Well, what we do is we still have a tens value that we can put in there. Anything that only is a one-digit number has a 0 in the tens place. So if I was putting in the numbers 7 and 8, I'd need to put a 0 in the stem to represent 0 tens, and then 7 and 8 in the leaf to represent those specific numbers. So we represent one-digit numbers, 1 through 9, 0 through 9, with a 0 in the stem and the number in the leaf. So the other thing that'll mess people up is really big numbers, and this is going to relate to you all when you are, or some of you at least, when you're trying to make a stem and leaf plot of some of your name data. So if you've got really big numbers, like 125, 127, 129, you're going to do the same thing that you did before, break it up into two pieces, except what goes into the stem is now going to have more than one digit. So let's take the one we've already done as an example. My lowest number is 94, so I'll split that in two pieces. I'll put a 9 in the stem, a 4 in the leaf. Here's a 98, same thing, 9 in the stem, already there, 8 in the leaf. Now we get into these higher numbers. My next highest number is 103. I'm still going to split that into two pieces, but I'm just going to keep counting up with the stem. After 9 here comes 10. And that's going to represent the first half of my 103. 103. So that's 103. If I want to put 104 in, same thing. 104. Okay? Here's a 114. I'm going to break that in two pieces just like before. In this case, 11 in the stem, 4 in the leaf. And I can keep moving on and doing that. So this top row, I've got a few 120s, 125, 127, 129. I'm going to put these in with a 12 in the stem and a 5, 7, 9 in the leaf. Last set would be these 130s. So for these, I'm going to put a 1-3 or a 13 in the stem, 130, and in the leaf is a 1-1-3. So that's how we handle larger numbers. If we got into thousands, we could deal with that too. We just have a 3-digit stem and still a 1-digit leaf. An important thing to remember here is that no matter what, you're never going to put more than a single digit into the leaf, because every digit in the leaf should represent a number. So this 4 is 94, this 8 is 98, this 3 is 103, this 4 is 104, and so on. Every digit in the leaf represents a separate number. So an easy way to tell how much data you had if you're looking at a stem and leaf plot is to just count the number of digits in the leaf. Every digit represents a piece of data. So here's an example of this again. I'm looking at a stem and leaf plot that's made, and I can go through and find out a lot of information about the data that I started with. I can say, for example, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of data originally. I could also calculate the mean, median, mode, and range of this stuff because conveniently a stem and leaf plot, the data is always in order. So I know my least value is going to always be this first number, and my highest value is always going to be this last number in the stem and leaf. So I could tell you right now, my highest number is a 44. It comes from the 4 in the stem, 4 in the leaf. And my lowest number is a 9. 0 in the stem, 9 in the leaf. So my range for this data, pretty easy to calculate. It's going to be 35. My highest minus my lowest. Let's back out here. If I needed to, I could list every piece of data in this set. First data, 9, 9. Next row, we've got 1 in the stem, 0 in the leaf, so that's going to be a 10. And then an 11, 2 12s, a 16, and so on. I won't list everything out, but you could if you needed to. The other thing you could do, if you needed to, is that you could very easily figure out the mode of the data. You just look for what number in what row repeats most often. In this case, I can see I've got 2 of these 9s, 2 of these 2s, and 2 of these 6s. A common mistake would be to say that the mode was 2, 6, and 9. In fact, the mode is 9, 12, and 26. Because remember, these digits don't represent the whole number, they represent a piece of the number. So 2 6s in this third column, or third row, actually represents 2 26s. So my modes would be 9, 12, and 26, not 2, 6, and 9. Let's talk about a couple quick things you should never do with a stem and leaf. One is this that we're looking at right now. The stem is ordered really well. This actually looks nice. You've got 8, 9, 10, 11, counting up. And I can see here this first data says 85, but that's not my least data, and that's the problem here. This data is not in order from least to greatest, so it should not look like that. Any good stem and leaf plot starts with the numbers in order, so this 81 right here is going to be my first set of data, so it should have been 1, 4, 5, 8 in the first row. Same thing on the second row. It should have been 2, 3, 5, 6, 6. Third row should have been 0, 1, 2, 7, 8, and the last row should be 3, 5. So the data does need to be ordered from least to greatest. You should never be jumping around randomly. It's a good reason to maybe order your data before you make a stem and leaf plot. Here's another thing you should never do, even if this data was in order, is put commas between the numbers. Again, the whole idea of a stem and leaf plot, the thing that every stem and leaf plot should have in common, is that every digit in every row represents a number. So commas aren't necessary because you know that this 5 is separate from this 4 is separate from this 1. The commas just make things look messy. So a good stem and leaf plot will not have commas between numbers. So one thing that you should probably ask yourself at some point is, well, what's the point of a stem and leaf plot? When would I ever make it? Lots of graphs have really obvious uses. A stem and leaf plot is actually not seen frequently. In all honesty, the most important place that you'll probably see it is on a standardized test or your SATs and things like that. If you saw a stem and leaf plot outside that scenario or in a classroom or outside a classroom, I would honestly be surprised because they're not wildly useful. Beyond that, we can say that stem and leaf plots are really good for organizing whole numbers. It can only really be used for whole numbers, so only for numerical data and only for numerical data that is in whole values. The other thing we could say about it is that it's really good if you want to be able to see the data. It's one of the only types of graphs or charts where you're guaranteed to have the data available to you because it's part of what you make it with. And that's pretty much it. Here's some practice problems for you. In number 1, I'd like you to look at that stem and leaf plot, think about what data it's giving you, and find the median, mode, and range for it. And on number 2, I'd like you to make a stem and leaf plot for the data that you see there. Alrighty, have fun.